Hello, my name is Robert Coleman, and I am presenting my research under Dr. Tom Devine on classifying big data in a DCE, or distributed computing environment. Radio astronomy is the key to understanding our universe, and the amount of data received from observations is large and unbalanced. The astronomy data we focused on for this project were pulsars. Pulsars are neutron stars that emit electromagnetic radiation from their poles. They spin at alarmingly fast rates, some as fast as 700 times per second, are the size of a small city, and are incredibly important to astronomy research. Neutron stars result from the death of high mass stars when an influx of neutrons compress together at the center. Their electromagnetic radiation is measured by radio waves and recorded in the Presto suite for tangible data. Distributed computing environments allow us to take in that data and process it for astronomers to read. This helps us categorize pulsars, thus eliminating time of looking through tons of poor data. But why have a DCE in the first place? If all we're doing is sorting data, what is the point? Would it not be easy to tell the difference? Well, the simple answer is no. Most data is clouded with space RFI, or radio frequency interference, generated by things like satellites, the internet, spark plugs, and radio stations. DCEs allow a computer to analyze data and categorize it as good or bad for further analysis. So why do something when you can have a machine do it for you? Radio astronomy is a form of big data. Big data is huge, so huge that humans could not possibly process it all on their own. We need new software to more efficiently process it. Algorithms need to be tested repeatedly to see what works and what does not. Semi-supervised machine learning algorithms, like Dr. Devine's CoDrift, allow us to effectively and precisely label data in a manner that makes classification easier with less direct human involvement. For this project, Apache Spark and Scala were set up in a Windows subsystem for Linux terminal to emulate the connection of nodes or computers together. From there, the semi-supervised machine learning algorithm will be implemented, and further parallel distributed computing environments will be performed. The CoDrift algorithm is a semi-supervised machine learning algorithm developed by Dr. Devine. By looking at Figure 2, we can learn how the process from data collection to computation will work. Radio waves emitted by interstellar objects are picked up by sensitive radio telescopes, where the data is then processed by specialized software called Presto. Our research uses a DCE to identify candidates in the output from Presto, train CoDrift learners on those candidates, and then classify them. Dr. Devine's preliminary results have shown that CoDrift is very good at creating classification models with very little labeled input. We intend to expand on those preliminary results by performing additional classification experiments to explore ways to tweak the code for further optimization. The results should show us that we can confirm the products from semi-supervised machine learning, distributed machine learning algorithms to match our original data sets. It will reduce the amount of time that was previously used to classify pulsars by reducing the manual labor required. We anticipate CoDrift to become more precise after rounds of testing to show the algorithm's improvement. Thus, the semi-supervised machine learning algorithms will improve our classification precision of pulsars to help astronomers sift through the big data gathered by radio telescopes to make new discoveries. In the future, we will further improve CoDrift by testing it to enhance our knowledge of pulsar classification. We will also try to generalize CoDrift for other applications outside of pulsar classification to increase its overall utilization outside of astronomy. This means it could be implemented in more common areas like cybersecurity and fraud detection. Additionally, we will try to include more massively unbalanced data sets to test the versatility of CoDrift. Thank you for attending my presentation. I hope you learned something new today, and if there are any questions, I would be happy to answer them. Have a great day.